Then I talk about polygon acceleration rotation with sliding effects. Introduction to Coriolis acceleration. Coriolis acceleration is the quickest form observed in rotating reference systems. It affects the motion of objects with moving within a rotating system such as spinning disk. Understanding the acceleration is essential for analyzing dynamics and rotating machinery systems. Rotating disk system overview. Considering a disk rotating with constant angular velocity, mass sliders tap rapidly radially on the disk influenced by both gravitation and internal forces. The system provides a practical scenario for study Coriolis effects on moving masses. When a mass is moving in a rotatory system, such as disk rotating with a constant angular velocity, it experiences additional acceleration that can do exist in stationary frame. This acceleration arises due to the rotation of the reference frame and include the centrifugal acceleration and Coriolis acceleration. Direct essential acceleration directed outward from the axis of rotation. Coriolis acceleration acts perpendicular to both of the rotation axis and direction of motion of the mass. The study of Coriolis acceleration is essential to understanding motion dynamics and rotating reference, particularly systems like rotating machinery, gyroscope turbines, and even large-scale phenomena such as atmospheric ocean mode on Earth. Studying a disk rotating with a constant angular velocity at about central axis, a mass slides radially along a groove on the surface of the disk. If the mass moves radially outward or inward the velocity, it will experience an additional acceleration due to rotation. This is the Coriolis acceleration. The Coriolis acceleration always acts perpendicular to direction of sliding of the motion. The direction depends on whether the mass will move towards away from center and direction of the rotation. Basic concepts of rotational dynamics. Rotational dynamics deals with the motion of bodies rotating with an axis. Key quantities include angular velocity, acceleration, and moment of inertia. In non-inertial frames, additional inertia forces like polaris and centrifugal forces arise. Reference frames in the system. The rotating disk defines a non-inertial reference frame force due to rotation. An inertial frame observes the true motion of sliding masses is without previous effect. Motion of the sliding mass. The mass moves radially outward or inward depending on initial conditions. Its velocity relative which can be described in radial and tangential components. The motion is influenced by both the external forces and inertial effects on the rotation. Direction of cordless acceleration. The cordless acceleration always perpendicular to the radial motion. If the disk rotates clockwise, move over the backward, and acceleration acts it on opposite tangential direction of rotation. If the mass moves inward, acts in the same tangential direction of rotation. Energy conservation. When the mass slides radially, work is done by or against the centrifugal force, which affects in kinetic energy. However, the kinetic energy in this does not work as perpendicular to the direction of the motion. This is why auto circulation experimental demonstration rotating apparatus can be used. The disk rotated in three control angulation velocity. A small in groove or triangle. Derivation of cordless acceleration, it is the velocity of moving mass in a rotating frame. This is proportionally to across product of the angular velocity of the masses. The mathematical expression is radial component and tangential component angular velocity of the disk, radial radial distance of mass from the center, radial velocity and radial acceleration. Electrical magnitude equal to A equal to root over R minus RW, gamma minus gamma W square whole square plus 2 W gamma whole square. Effect of Coriolis and radial motion. When the mass moves radially, Coriolis acceleration produces a tangential component. This tangential component causes the masses to derive from purely radial motion. The derivation depends on magnitude of radial velocity and rotational rate. Then the mass that is radially work is done by the against the centrifugal force, which affects its kinetic energy, how the correlates force and this solid acceleration that work its action perpendicular to the direction of the motion. This is why Coriolis acceleration change the direction of the motion is not speed. Sensors measure it may radially velocity and acceleration when observed from a stationary frame and the path appears curved due to Coriolis reflection. If the effect on tangential motion, if the mass has tangential velocity component, Coriolis acceleration influences radiation motion. The resulting motion becomes a combination of radial and tangential displacement. The interplay affects the overall trajectory of the sliding masses. Components of acceleration rates of sliding velocity by gyroscope and navigation systems, meteorology and oceanography. The Coriolis affects the explain large-scale phenomena like rotation cyclones and trade wind patterns on Earth due to its rotation. Machine and rotating equipment, aerospace engineering and fluid dynamics. Aerospace engineering is in designing sensors like Coriolis vibratory gyroscopes for aircraft and spacecraft attitude control and fluid dynamics. But the Coriolis affects influence flow paths in rotating fluids. Importance in engineering analysis. Breakthrough modeling helps engineering models dynamic systems operating in rotating film. Design optimization minimizes unwanted forces of vibrations caused by Coriolis effects. Measurement accuracy. Importance for interpreting sensor data in rotating systems. Safety and reliability prevents mechanical imbalance and wear due to uncounted forces. Implications of energy and momentum. Coriolis acceleration can alter the angular momentum of the mass. It influences the kinetic energy distribution between radial and tangential components. Proper accounting is necessary for energy conservation analysis in rotating systems. Experimental setup for observation. A rotating disk is apparatus with the sectional sliding mechanism is also a high-speed cameras or sensors track the masses during rotation. The data collected helps visualize the influence of Coriolis acceleration. Analytical solutions. The one predictions equations of motions are driven considering the centrifugal Coriolis and gravitational forces. Solutions predict the mass under the various models help validate experimental observations. Practical applications of the study. Inside the applicable in designing rotating machinery and centrifuges, understanding Coriolis effects control in rotating spacecraft compound. The analysis enhances navigation system that rely on rotating frames. Limitations and resistance. Rigid body rotation with constant angular velocity neglects frictional forces and resistance for simplicity. Research direction, extending the analysis to non-uniform rotation, accelerating discuss, study the effects with the multiple masses integrating on the disk, incorporating frictional and damping effects of one more scenarios. Conclusion: the Wallace of acceleration plays a crucial role in the dynamics of sliding masses on rotating disks, generating these effects enhances the design and rotating systems. Ongoing search are unable to uncover. Thank you.